So in this module, we're going to cover Chapter 2 of Wooldridge. And in particular, this chapter covers the simple regression model. So as we kind of discussed before, a lot of times in economics, we're interested in the effect of one variable on another. Often interested in the influence of one variable on another. Right, so we might be interested in particular, probably the causal effects. A lot of time we're interested in the causal effects, like we discussed in that last, or in that first kind of introduction module, this idea of causation versus correlation. We're usually interested in these causal effects. So let's think of a couple of examples. And you can think of so many examples probably right off the top of your head. Might be the effect of education on earnings. For instance, the return to education. So we're interested in how does one more year of school affect your earnings? Maybe we're interested in human capital accumulation or something like that. We could be interested in the effect of discrimination on wages. We could be interested in the effect of unemployment on minimum wage, or minimum wage on unemployment, I should say. And so here we kind of have to expand these estimators that we are talking about. We have to introduce new estimators from what we were talking about in that appendix to kind of relate two variables to each other. And so we need to come up with some kind of functional form that allows us to relate two variables to each other. So that's what we're going to look at next. And we can think of kind of three kind of broad issues with trying to kind of write down a model of this relationship between y and x, or two variables. Let's call them y and x. Three issues. The first issue is going to be, how do we allow other factors? How do we allow other factors besides, let's say, x to influence y? So let's say we have two variables, x and y. We're trying to figure out how x affects y. Well, how do we allow other factors? We know there's lots of things that might affect wages, besides education, for instance. How do we let those other factors affect y? The second question relates to the actual relationship between y and x. So what is the functional relationship? BTW for between y and x. So is it a linear relationship? Is it a nonlinear relationship? We need to come up with a functional form for this relationship. We need to write down something about this relationship. And the third is, how can we capture the ceteris paribus relationship? Relationship between y and x. So, different things are changing all the time. How do we hold everything else constant that's happening in the world? We probably have all these other factors that are affecting y besides this x we're interested in. All these other factors affecting wages besides education. Well, how do we hold all those other factors constant? Experience, location, race, all these kind of things that are influencing people's wages. How do we hold those constant and just concentrate on this relationship between education and wages, if that's what we're interested in? Okay, so let's kind of write something down and talk about how the model that we write down is kind of trying to deal with those three issues we just talked about, or how it's dealing with it, or trying to, I should say. Okay, so let's write down y equals beta 0 plus beta 1 x1 plus u. Let's talk about what each of these things means, or is. So y is our dependent variable. It's just the variable we're trying to explain. So for instance, one of the examples we've been talking about is this returns to education. So we're interested in explaining wages. So the next two things we're going to talk about are beta 0 and beta 1. These are parameters. And these are the true parameters because they have no hats on. Usually when we estimate something, we put a hat on them, so these are the true parameters. So these are things that are affecting the distribution of wages, just like we saw in that appendix. We have these parameters that are affecting the distribution of wages. We want to learn about these parameters. We want to use the sample, use our rule, use our estimator to try to learn something about the value of these parameters. x1 is the independent variable. So for instance, education. We're interested in the effect of education on wages. So maybe that's what this kind of beta 1 is trying to capture here. And finally, we have this u. This is the error term, sometimes called the disturbance. This is basically all other factors influencing y. So the idea here is that we're kind of specifying this relationship between x1 and y, and how we're dealing with everything else is to kind of just throw it in this error term. This is kind of an unobserved error term. We don't actually get to see that, right? This is how we're dealing with that first issue. How do we deal with all the other factors that are affecting wages other than education? Well, we're going to just throw it in this error term for now. We're going to have to deal with that at some point, and we'll talk about issues with that. But that's how we're dealing with that first issue. All right, in terms of the second issue, why don't I just erase this to give myself a little bit more room, and we'll talk about the next couple issues. All right, so let's just rewrite this model up here so we can keep it in mind. Y equals beta 0 plus beta 1 x1 plus u, just so we can refer to that as we go. All right, so in terms of the second issue, it's about the relationship between x and y, or y and x. And how we wrote this out, it's implying the relationship between y and x is linear, right? Because a change in y equals beta 1 times a change in x1 if nothing else is changing. So think of this as the slope. And so we're kind of making this assumption. As soon as we write out a model that looks like this, we're making the assumption that the relationship between x1 up here and y is linear. So what does this mean? Well, what does this imply about the relationship between y and x? Well, it implies a 1 unit change. It's a delta for a change, just like this is a delta and this is a delta for a change. A 1 unit change in x has the same effect effect on y, regardless of initial value. Initial value. Hopefully that's still on the screen for you guys. Okay, so it's implying that a 1 unit change, the relationship is linear. It's implying that a 1 unit change in x causes a 1 unit change in y, or has the same effect on y, regardless of the initial value. Well, do you think that holds? I mean, this is a kind of a big assumption we're making, right? Think about, I don't know, experience. Usually the first couple of years of experience you gain after high school or when you first start working or university or whatever, you learn a lot and you're really rewarded. Your wages go up a lot for those first few years of experience because you learn a lot. They probably go up a lot more from those first years of experience than going from, let's say, 34 to 35 years of experience. So maybe experience is like a nonlinear or decreasing returns. This model is not. How we wrote this out is not allowing that. So let's just keep that in mind. All right, so we've kind of discussed how that, model we wrote down, that y equals beta 0 plus beta 1, x1 plus u. We kind of discussed the first of those two issues when dealing with a model like this. So the functional form, as well as how we're dealing with other variables. So that first one is about other variables. We're sticking them all in that u, that error term here. What functional form do we have in this relationship? Well, we've kind of made the assumption that it's linear right now. That third issue that we had is how do we get that ceteris paribus relationship between x and y? How do we hold everything else constant? How can we get the ceteris paribus? Ceteris paribus relationship. Okay, this is going to be the most complicated issue. Most complicated of these three issues. Okay, so we need to start making assumptions about the relationship between x and u. Remember, all these other factors are in u. So now we need to start making assumptions about the relationship between these two. But both of these two things are random variables, which means that these assumptions are going to be based in probability. So we need to make, hopefully you can see that, assumptions about the relationship between x and u. But x and u are RV for random variables. So we must use probability to kind of talk about the assumptions of the relationship between these two variables. So that's what we're going to talk about now. In particular, we're going to kind of talk about two assumptions. The first one is kind of something we could kind of make happen anyway, but the second one's going to be a huge assumption we're going to be making for the next little bit.